Now let's go ahead and look at logarithmic functions and their graphs. So the first step is to identify the domain of a log function, and then we're going to graph the logarithmic function. To do that, let me go ahead, open up my Desmos here, and I'm going to go ahead and plug in my log. Did I miss it? Yeah, log x. And you can plug any log, but what you'll see is the logarithmic function, the domain of the logarithmic function is always positive. I don't have a log on the negative side. My log is only on the positive side. And if you look closely, this is your asymptote. Do you see that? The y-axis is your asymptote, and this is your x-intercept, 1, 0. All right, so let's take a look at the first domain. They're asking us to identify the domain of log x power 6 base 5. So the base does not matter. What you do is you take x plus 6, and remember, this should be positive. It should not be equal to 0 because I don't have a log of 0. So this should be greater than 0, not equal to, greater than 0. Why? Because if I plug a log of 0, log parentheses 0, log of 0 is undefined because it's an asymptote. You see that? It's an asymptote. So it should be greater than 0. What does that mean? When I subtract 6 from both sides, what do I get? X should be greater than negative 6. How do I write this in interval notation? Parentheses, negative 6, all the way up to infinity. You can go ahead, graph this in your Desmos and see if that is your domain. So I'm going to graph log. I'm going to go back to my functions. Actually, you know what? Let me go back to my function so I can plug in a base. Where is my calculus? Yeah. Log x plus 6, and the base here is 5. And as you can see, my function is greater than negative 6, going all the way up to positive infinity. And I do not have the value at negative 6. When I plug negative 6, it's going to be undefined. Remember, it should not be equal to negative 6, but it should be greater than negative 6. Now let's go ahead and find the next one. Remember, all I do is the base doesn't matter. I'm going to simply take the one inside the parentheses. 7 minus x should be greater than 0. I add x on both sides. What do I get? 7 has to be greater than x, or in the other words, x has to be less than 7. How do I write that in interval notation? Less than 7 is negative infinity to 7. Less than is to the left side, remember. Again, you can graph this and find out. Now the next one. Remember, I only take this. So x minus 7 squared should be greater than 0. X minus 7 should be greater than 0 because when I square root of 0, what do I end up with? 0. So x has to be greater than 7. Interval notation, greater than 7 to infinity. All right, let's take a look at the next one here. What do I have? 2x plus 3 has to be greater than 0. Subtract 3 on both sides. I have 2x greater than negative 3. Divide by 2 on both sides. X is greater than negative 3 over 2. How do I write that? Greater than is negative 3 over 2 all the way to infinity. Okay, again, make sure you graph these in Desmos just to cross-check your domain. All right, now let's go ahead and do the easy part of graphing. Remember, the graph of a log function has to pass through 1, 0 because log 1 is 0. So that's always going to be my intercept and my reference. And Remember the log function, the 0 is the asymptote, so it doesn't touch it. And there you go. That's my log function. Now for the next one, you know what? Let's go ahead and draw the one below. Again, this is a log function. You have your Desmos. The reference is 1, 0. It doesn't matter what the base is. Remember, I'm not plotting it. I'm sketching it or graphing it. So that's how it's going to be. Every log function should pass through the point 1, 0. Now let's take a look at the next one. So this is x minus 2. There's a transformation. That means I move 2 units to the right. So this is my reference. Remember, this is my reference. I'm going to go ahead, cross, right? But remember what's happening? The graph moves 2 units to the right. So 1, oops. So I move it 1, 2. 2 units to the right. That's my new function. And here my asymptote is going to be 1. The graph comes all the way down. And this new point is 3, 0. This is 2. This is x is equal to 2. And my graph passes through 3, 0. Because my intercept is 1, 0. Remember I moved 2 units to the right. 1, 2. 1, 2, yeah. And that's from 1 I go to 2, from 2 I go to 3. So my new point is 3, 0. Now let's take a look at this one. I'm gonna erase this. Again, my reference is 1, 0. What's happening to my graph? My graph is moving 5 units to the, not to the right or left, but I'm moving 5 units up. So this is going to be 1, 2, 3, 4, 5. This is where my new point is going to be. So what I'm going to do is I'm going to graph the log function. And once I graph it, I'm going to grab it and I'm going to move 5 units up. And that's going to be a new log function. And this is going to be 1, 5. All right, again, always cross-check with your Desmos to make sure you're on the right track. But because you know transformations, you can simply go ahead and graph it.